In question number 19, you are asked, the diagram below shows a trough whose cross-section area is an isosceles triangle ABC, in which BC is 1.4 meters and AB is equal to AC and it is 90 centimeters. So the length of the trough is 7.5 meters. So part A, calculate to the nearest whole number 1 the cross-section area of the trough in centimeters squared. Now, the cross-section is an isosceles triangle. So the area of the cross-section is a half base times height. So height using Pythagoras theorem will be given by 90. 90 is the hypotenuse and the base is half of 1.4, which is now 70 in centimeters. So we are going to say height squared is going to be given by 90 squared minus 70 squared. So height squared is going to give us 3200. So the height will be given by the square root of 3200. So the height here is simply 56.57 centimeters. Now we can use the height now to find the cross-section area. You say area is equal to a half times the base, which is 140 centimeters multiplied by 56.57. So the area here will be given by 3,959.9 centimeter square. Now to the nearest whole number, the area will therefore be 3,960 centimeter square. Still in part A, 2, you are asked find the capacity of the trough in liters. So we are going to say the capacity of the trough is cross-section area multiplied by the length of the trough. So this one will give us capacity is equal to half base times height times length. So we already got the cross-section area as 3,960 centimeters square. Now we can multiply by the length, 7.5 meters, which is 750 centimeters. So this one will give us the volume or the capacity as 2,970,000 centimeters cubed. Now we know 1 liter is equal to 1,000 centimeters cubed. Therefore, we are being asked to give the volume in or the capacity in liters. So we are going to divide 2,970,000 centimeters cubed by 1,000 and we get the volume as 2,970 liters. So in part B of the question, the trough, which is initially empty, is filled by a pipe whose internal diameter is 3.5 centimeters, through which water flows at the rate of 50 meters per minute. Giving your answer to the nearest minute, calculate the time in hours and minutes it takes to fill the trough. Solution: we have to find the amount of water that is passing through a given section of the pipe per minute. So we are going to use the formula volume is equal to pi r squared length. Now we know the radius is half of the diameter, so it is going to give us 22/7 times 1.75 times 1.75 multiplied by the length 50 meters, so 5,000 centimeters. So the volume is 48,125 centimeters cubed. So in liters, this one will be given by 48 liters, 0.125 liters. Now, the rate is 50 meters per minute. So in those 50 meters in a minute, there is 48.125 liters passing at that section. So 48.125 liters is equal to 1 minute. So what about 2,970 liters? The capacity of the whole given truck. So we are going to say 2970 divided by 48.125 multiplied by 1. So 61.74 minutes. Now converting 61.74 minutes, we shall get 1 hour, 2 minutes, giving the time to the nearest minute. So part C, the trough is used to water the livestock in a farm. Each of the livestock drinks 2.5 liters at a time for 3 times a day. If the trough is initially full, find the number of days it will take 44 of the livestock to drink all the water. Now, solution. We deal with one of the livestock. When dealing with one livestock, you are going to get 2.5 multiplied by 3, you get 7.5 liters per day. Now, we have 44 livestock, so we are going to say 44 times 7.5. So this one will give you 330 liters per day. So now we can ask, what about 2,970 liters? So we are going to get 2,970 divided by 330 multiplied by 1. So this one will give you 9 days.